Good morning, everyone. Welcome to the next experiment to plot the input and output characteristics of a BJT. For this, the components that you need is a resistor for the input bias. Just click on the resistor. Now, in addition to this, we need a transistor. So I'll just type NPN, press OK, and press Escape. Then we need a ground for the input. Then we need a voltage source. Input and at the output. Press Escape. Now we'll make the connections. Press Escape. Now once your connections are done, since you are plotting the input and output characteristics, we'll be just putting the namings. Just bring your cursor to V1. You see the change in the cursor. Right click. Now it will ask you for entering the name. I'll just name it as VBE. Similarly, I'll change the name of the output as VCE. Okay. Now the input resistor, I'll just set the values to 2K. And output resistor, I'll set it to 62K. I'll select the transistor as PC547B. Press OK. I'll just set the values of DC to be 0 for now. Now for plotting the input characteristics, we want IB with the changes in VBE for different values of VC. Similarly, for output characteristics, we want IC with the change in VCE for different values of VB. For this, we will be using the DC sweep. So just go to the run. Click on DC sweep. Now you see three sources, first source, second source, and the third source. The first source is what is varying or changing in the x-axis. So for the input characteristics, we want VBE to change. Linear sweep. Let's mark it as 0 to 2 volts in an increment of 0.1. Second source, let's take it as VCE. Say 0 to 5 in an increment of. Now we will run this. Now to have a better visibility of the output, we'll just go to the windows and select time vertically. Now to change the background from black to white, we'll just click on this window and go to the tools, color preferences. In that selected items, select the background and put all the colors to 255 and press OK. Now this gives us a better visibility of the results compared to the black window. Now what we want to see is IB. So again we just run it. Bring our mouse near to the base till this red probe converts into a black probe, which will give us the current. Red probe gives us the voltage. So now this will give us a current at the base. Now click here. Get the characteristics. We can just zoom in to have a better visibility of the input and output characteristics. We can just zoom in to see what is the change in the or variation. We can check the legend also by right clicking in this window. Go to the view and step legend. So this shows us what are the different values of VCE. For VCE1, the blue line and so on. With the changing VCE, the curve is changing its shape and moving downwards with increasing VCE. Now we want to see the output characteristics. So we just bring our mouse here, right click. Now for output, we want x-axis to be VCE. We just change it, and y-axis to be VBE. Here we will just keep it as 0 to 0.1 and in an increment of, and bring our mouse to see the collector current. We can clearly see the output current with the changing VBE. Again, we can check the legends. So at every 100 millivolt that we get a plot, and it clearly shows that with an increasing VBE, the output current is also increasing. From this plot, we can actually define the linear region and the saturation region. So this finishes the first part of plotting the input and output characteristics.